According to a NASA insider, Voyager 1 has made contact with an unknown force in space. After more than 40 years of solar system exploration, the Voyager spacecraft have reached unexplored deep space. Scientists are intrigued to learn more about the enigma surrounding these amazing happenings after Voyager 1 made contact with an unidentified entity. Recently, an unexpected change in the magnetic field around the spacecraft was picked up by an instrument, indicating the presence of a magnetic effect. The volume and duration of the disturbance were unlike anything they had ever seen, which led NASA scientists to question their initial hypothesis that a cosmic ray or high-energy particle traveling across space would be the source. The magnetic field surrounding Voyager 1 looked to be under the influence of this unidentified force, which was causing it to oscillate in a way that NASA scientists could not understand. It nearly appeared as though the spacecraft had run into an unseen barrier. NASA scientists are constantly trying to figure out what this mysterious energy is all about. They're exploring a wide range of scenarios, including intelligent extraterrestrial life and unusual astrophysical phenomena. Some have suggested that dark matter may be to blame for the disturbance. This unknown force in deep space detected by Voyager 1 has left everyone startled. Voyager 1, a NASA spacecraft, was launched after Voyager 2, but because to a quicker path, it left the asteroid belt before its twin on December 15, 1977. In April 1978, while it was roughly 165 million miles, 265 million kilometers from the planet, it started its Jovian imaging mission. Jupiter's atmosphere appeared to be more tumultuous in images returned by January 1979 than it had been during the Pioneer flybys in 1973 to 1974. Voyager 1 started taking pictures on January 30, 1979, and continued doing so every 96 seconds for a total of 100 hours. This resulted in a color time-lapse movie that showed 10 rotations of Jupiter. The spacecraft entered the Jovian moon system on February 10, 1979, and in early March it found a thin ring, less than 30 kilometers or 19 miles thick, encircling Jupiter. The quick and unexpected change in the magnetic field measured by the spacecraft suggests that the source of the disruption may be an unknown external influence. One probable explanation for the unknown power is that Voyager 1 came into contact with an unidentified cosmic ray. These high-energy particles are assumed to come from outside our solar system and have the ability to influence the behavior of charged particles in the heliosphere. Another theory is that the disruption is caused by a coronal mass ejection. This is a large solar plasma explosion that can cause problems in the interplanetary medium. The extent and length of the disturbance identified by Voyager 1 suggests that the unknown force's source may be more concerning than previously anticipated. 5 new moons were discovered by Voyager 1, along with a ring system with thousands of bands, wedge-shaped transient clouds of minute particles in the B ring that were dubbed spokes, a new ring, the G ring, and shepherding satellites on either side of the F ring that maintain the ring's sharp edges. The spacecraft captured images of Titan, Mimas, Enceladus, Tethys, Dione, and Rhea during its flyby of Saturn. The incoming data suggested that all the moons were primarily made of water ice. Titan was the target that Voyager 1 passed by at 5:41 UT on November 12, 1979, at a distance of roughly 2,500 miles, 4,000 kilometers. After the collision with Saturn, Voyager 1 set out on a course to leave the solar system at a speed of about 3.5 AU, 325 million miles or 523 million kilometers per year, 35 degrees to the north of the ecliptic plane, and roughly in the direction of the sun's motion with respect to nearby stars. The spacecraft was not pointed at Uranus and Neptune due to the unique needs for the flyby of Titan. The first portrait of our solar system as viewed from outside was created on February 14, 1990, when Voyager 1's cameras were oriented backward and took roughly 60 pictures of the sun and planets. The photos were captured at a distance of 40 AU, 3.7 billion miles or 6 billion AU from the sun. The new mission's general objective is to extend NASA's exploration of the solar system beyond the vicinity of the outer planets to the outer limits of the sun's sphere of influence and possibly beyond. Specific objectives include gathering data on the transition between the heliosphere and the interstellar medium, a 12-inch, 30-centimeter kilometer diameter gold-plated copper disc, manufactured by a team led by Carl Sagan, serves as each Voyager's message to any potential extraterrestrials who may come upon the ship. Similar to the plaques on Pioneers 10 and 11, the record contains symbols that depict Earth's position in relation to a number of pulsars. Similarly to a vinyl record player, the records come with instructions on how to play them using a cartridge and a needle. There are greetings in 55 different languages, 35 Earth sounds such as whale songs and laughter, and 90 minutes of primarily Western music, ranging from Mozart and Bach to Chuck Berry and Blind Willie Johnson. It also has 115 pictures of earthly life and greetings from former UN Secretary General Kurt Waldheim, 1918 to 2007, and former U.S. President Jimmy Carter, 1924 to present. The sun and its warmth are now nearly 11 billion miles, 18 billion kilometers, away from the two Voyagers. Mission engineers started putting a new management strategy into place for the older robots in 2019 to guarantee they keep providing the finest scientific data they can. Making difficult decisions is part of the strategy, particularly in regards to the spacecraft's instruments and thrusters. With the sole exception of experiments utilizing its photopolarimeter, Voyager 1 was successful on all fronts with regard to Jupiter. The discovery that Jupiter's atmosphere was more active than it had been during Pioneer 10 and 11's visits led scientists to re-evaluate past atmospheric models that were unable to account for the novel phenomena. The moons, Amalthea, Io, Europa, Ganymede, and Callisto were observed by the spacecraft, revealing for the first time the features of their surface. The fact that Io has tremendously active volcanoes that are heated by the stretching and relaxing the moon experiences every 42 hours as its elliptical orbit moves it closer to and then farther away from Jupiter was perhaps the most astounding of Voyager 1's discoveries. This discovery altered how scientists thought about the moons. The second spacecraft to orbit Saturn was Voyager 1. More thoroughly than its predecessor, Pioneer 11, it investigated the planet, its rings, moons, and magnetic field. With the exception of the experiments intended for its photopolarimeter, which did not function, Voyager 1 achieved all of its objectives. Prometheus, Pandora, and Atlas, the shepherding moons that keep the F-ring clearly defined, and the moons that similarly shepherd the A-ring, were discovered by the spacecraft. Voyager 1 was the first spacecraft to enter interstellar space in August 2012. It will stay in the solar system until it leaves the Oort cloud in another 14,000 to 28,000 years. Though if we define our solar system as the sun and everything that principally orbits the sun. According to recent findings in October 2022, scientists have found strange structures and ripples at the boundary between our solar system and the immense expanse of interstellar space beyond it. The findings demonstrate that the solar system's protective heliosphere, or heliosphere, varies in ways that are intriguing and potentially controversial, the paper notes. More than twice as long as Pluto's orbit, the heliosphere stretches out into space for around 11 billion miles. The solar wind, a stream of charged particles released by the sun, is what shapes the heliosphere. The heliopause, where the solar wind gives way to the pressures of the interstellar medium, marks the edge of this structure. The 1977 launched NASA Voyager 1 and 2 spacecraft have both passed this limit in the last 10 years, making them the first artifacts built by humans to travel into interstellar space. The Voyagers are still sending messages from beyond the heliosphere, but they are only able to provide information about the conditions local to them. While much of this transitional area is still unknown, scientists have learned to map parts of the heliopause's broad contours by keeping an eye out for emissions from energetic neutral atoms, ENAs, which are produced by interactions between the solar and interstellar winds. Do not forget to subscribe for more amazing content. Also, turn on post notifications. At a distance of 121.6 AU from the Sun, Voyager 1 crossed the heliopause in 2012, while Voyager 2 did it in 2018. The heliopause surface was actually moving over this time by tens of astronomical units, as Zernstein and his colleagues found. For instance, the heliopause grew for years after Voyager 1 crossed this limit as if it were chasing it, even though the border never again overtook the probe. As a surfer on the edge of a wave, Voyager the 2nd of May have spent years just within the expanding heliopause before finally entering interstellar space. Voyager 2 crossed the HP in late 2018 at 119 AU from the Sun, and the analysis yielded a distance in mid-2016, which is much closer to the Sun, Zernstein said. To the best of our knowledge, within the uncertainty of the analysis, Voyager 2 was still at the heliopause in the middle of 2016. As a result, It can be inferred that Voyager 2 was just inside the heliopause in mid-2016, and that the heliopause must have been expanding outward for a while before the spacecraft finally crossed it in late 2018. NASA scientists are still trying to figure out what this strange force is. Check out our next video to actually find out what this mysterious force is.